I am David Attenborough, and I am 93. I've had the most extraordinary life. It's only now that I appreciate how extraordinary.
In the beginning, there was darkness. A vast, silent emptiness stretched across the newborn solar system. Within that stillness, dust and gas drifted endlessly, remnants from the explosion of ancient stars. Tiny particles of carbon, silicon, and metal floated in a golden haze, circling a young, glowing sun that pulsed with violent energy. This was no peaceful dawn. It was chaos. Gravity pulled everything inward, forcing matter to collide, shatter, and merge again. For millions of years, the fragments of cosmic debris spiraled around the sun, forming a swirling disk of destruction and creation. Within this fiery storm, a small region began to gather more dust than the rest. Collisions became constant, each one fusing fragments together into a growing sphere of molten rock. And from that chaos, the Earth was born. It was not yet the world we know. It was a red-hot inferno, a sphere of glowing magma, spinning faster than today, bombarded every few seconds by asteroids the size of mountains. The air was thick with vaporized rock and metal. There were no oceans, no sky, no continents, only a molten surface that shimmered like liquid fire under the glare of the young sun. Time passed differently in these ages. What felt like eternity to us was only a blink in cosmic time. For tens of millions of years, the Earth continued to grow, swallowing smaller worlds that crossed its path. Each impact melted its crust anew, heating it beyond imagination. Then came a collision unlike any other. A wandering planet, roughly the size of Mars, struck the young Earth with unimaginable force. Mountains vaporized in seconds. Both bodies fused together, and from the explosion, a cloud of molten rock was thrown into space, encircling the planet like a fiery halo. Within months, that debris began to gather, pulled by gravity into a single glowing sphere, the Moon. The Earth and its moon were now forever bound. Their dance would shape tides, seasons, and the stability that would one day make life possible. But for now, the Earth remained hell itself, a seething ocean of magma beneath a suffocating atmosphere of carbon dioxide, sulfur, and steam. Volcanoes erupted endlessly, painting the horizon with fountains of fire. Lightning flashed through thick clouds of ash, igniting storms that raged for centuries. Comets, carrying water ice from the outer solar system, began to strike the surface, each impact releasing steam into the atmosphere. The air grew heavy with vapor, and rain began to fall for the first time, not gentle drops, but torrential sheets of boiling water that hissed upon contact with the molten rock below. For countless years, this cycle of fire and water continued. Rain cooled the crust, but new eruptions split it open again, releasing rivers of lava that reshaped the planet's face. Gradually, the fiery glow began to fade. The crust thickened, solidifying into the first rocky surface. Volcanoes still burned, but the oceans were forming. Clouds blanketed the sky, and the temperature slowly dropped. In this early chaos, the building blocks of the future were forged. Deep beneath the crust, heavy elements sank to the center, forming a molten iron core. Lighter materials rose to form the mantle and the crust. As the core rotated, it began to generate a magnetic field, a shield that would one day protect the planet from the deadly solar winds. Above, the atmosphere began to shift. Though still toxic, it thickened enough to trap heat, preventing the oceans from freezing. The first continents, small and fragile, appeared like islands in a vast ocean of fire. The Earth was stabilizing, but its surface remained violent, reshaped daily by earthquakes and impact. In space, the sun continued to blaze, sending waves of radiation across the solar system. But the Earth now had a companion, the Moon, whose gravitational pull began to slow the planet's rotation. Days that once lasted only 6 hours stretched into 12, then 16, and eventually into the 24-hour cycle we know today. The tides created by this lunar pull stirred the early oceans, mixing chemicals that would one day play a vital role in the birth of life. As the young sun aged, it calmed slightly, allowing more stable conditions to form. Volcanic eruptions released vast amounts of gases, carbon dioxide, nitrogen, and water vapor, which began to form the early atmosphere. The constant bombardment from space finally slowed, and for the first time, the planet began to rest. Beneath its cooling crust, deep in the mantle, tectonic activity was already beginning. Continents drifted, collided, and broke apart. The crust cracked, forming the first ocean basins. And within those basins, rainwater and cometary ice began to collect. Slowly, the first true oceans formed, vast, dark, and acidic, stretching across the scarred surface of the young Earth. These oceans were unlike anything today. They boiled from below, heated by volcanic vents, and carried minerals from the planet's interior. Lightning from endless storms struck the surface, releasing bursts of energy that split molecules apart and reformed them in new combinations. The chemistry of creation had begun. Deep beneath the surface, lava continued to flow, shaping mountains that rose and fell within a single geological breath. Continents drifted above seas of molten rock, breaking apart and rejoining like pieces of a living puzzle. Above, the sky began to change color, from the dark red haze of volcanic smoke to the deep orange of a cooling atmosphere. Meteorites rich in carbon compounds continued to rain down, bringing with them the organic molecules that would one day become the foundation of life. Carbon, hydrogen, oxygen, and nitrogen, the essential ingredients mixed in the primordial oceans, the Earth was no longer a dead world. It was alive with chemistry. Lightning illuminated the turbulent sky, striking the surface again and again. Each flash created new compounds, complex molecules that drifted through the water. Over time, these molecules began to accumulate in sheltered pools and shallow seas. Here, the first steps toward life were being prepared, though still millions of years away from their true awakening. The Earth had become a place of balance between destruction and creation. Volcanoes continued to roar, but oceans now cooled their fury. Meteorites still struck, but less frequently. And within the planet's molten core, convection currents began to move, driving the tectonic forces that would shape the continents for billions of years to come. Beneath all this, the magnetic field strengthened, forming an invisible cocoon around the planet. Without it, the solar winds would have stripped away the atmosphere, leaving Earth barren like Mercury or Mars. Instead, the planet held on to its air, its oceans, and its potential. As millions of years passed, the skies began to clear. The first blue light filtered through the haze. Sunlight reflected off the surface of the oceans, shimmering across vast stretches of empty sea. Clouds drifted in the upper atmosphere, carrying the promise of a stable climate. But stability was fragile. Deep within the planet, the mantle churned restlessly. Continents cracked and drifted, releasing more gases into the atmosphere. Massive eruptions darkened the sky for centuries, then cleared, allowing sunlight to return. The Earth was learning to breathe, to inhale carbon through rock and exhale it through fire. The moon above, ever faithful, continued to pull at the oceans, guiding tides that shaped the coastlines. The rhythm of the tides became the heartbeat of the planet, setting the stage for the cycles that would one day sustain life. In these early ages, the face of the planet was constantly reborn. Mountains rose from volcanic fire only to crumble and sink beneath the waves. New islands emerged, covered in black basalt, still steaming from the heat below. The oceans absorbed minerals and salts, becoming rich in the elements necessary for future biology. Earth was no longer just a world of rock and metal. It had become a world of water, and with water came the potential for change. The atmosphere remained harsh, thick with carbon dioxide, methane, and ammonia. But within its chaos, sunlight broke through in golden streaks. Ultraviolet radiation reacted with gases, forming complex organic molecules that fell into the oceans. The chemistry of life was taking shape molecule by molecule. Above the sky was alive with storms. Thunder rolled across the horizon, lightning tearing through clouds that glowed orange and red. Rain poured endlessly, feeding the oceans and wearing down the sharp edges of new continents. Rivers began to carve valleys, carrying minerals from the mountains to the sea. Beneath the surface, hydrothermal vents erupted with boiling water and minerals, creating unique environments filled with energy. In these hidden places, deep in the darkness, the conditions for life quietly assembled. The world had transformed. From dust and fire came oceans and sky. From chaos came balance. Though still barren, Earth was now ready. The stage was set for the greatest story in the universe, the rise of life itself. But before that, one more transformation awaited. The planet still lacked something vital, an atmosphere that could sustain oxygen. For billions of years to come, volcanoes would continue to shape the air, filling it with gases that fed the chemistry of evolution. And slowly, from the bottom of the ocean, the first spark of life would emerge. The Earth had journeyed from cosmic dust to a living planet. Its scars told the story of violence and survival, of creation born through destruction. And though silent now, its heart, the molten core, still burned, a reminder of its fiery birth. From the void of space, the young planet glowed faintly blue, wrapped in thin veils of cloud. The storms calmed, the surface cooled, and the oceans reflected the light of the distant sun. In the quiet aftermath of creation, the Earth stood alone, fragile, powerful, and full of possibility. And in that silence, the universe waited for the first cell to form, for the first breath to rise from the deep, for the moment when chemistry would become biology. Everything that would ever live, every tree, every creature, every human waited in those waters, still only a dream within the memory of the planet. The birth of Earth was not the end of chaos, but the beginning of creation. From the ashes of destruction came the promise of life. And that promise, born in fire and water, would shape the destiny of the world for the next 4.5 billion years. The newborn Earth turned beneath a furious sun. Its crust cracked and hissed, seas of molten rock shifting like liquid glass. Volcanoes spewed rivers of fire, and the air above them shimmered with heat so intense it bent light itself. This was a world of endless twilight, a landscape shaped by violence. The Hadean age had begun. The ground trembled constantly, groaning from within as the planet struggled to cool. The crust was thin and fragile, breaking apart under its own pressure. Every few hours, another asteroid struck the surface, each one exploding with the force of millions of nuclear bombs. The impacts threw molten rock into the sky, and for days the horizon glowed with fire. The sky was not blue. It was a suffocating mix of black smoke and crimson haze. Ash fell like snow, settling on rivers of lava. No sunlight reached the ground, only the dull, flickering reflection of molten metal. Thunder roared without rain, echoing across empty plains of rock. The atmosphere was toxic, a thick soup of carbon dioxide, methane, sulfur dioxide, and steam. Clouds formed from vaporized stone, their undersides glowing red from the heat below. Lightning split the sky, creating storms that raged for centuries. Beneath those storms, the Earth was constantly reborn, melting and hardening again, each cycle rewriting the landscape. Deep inside, the planet's heart remained molten. Gravity had pulled heavy elements toward the center, forming an iron core surrounded by a mantle of dense silicate rock. Convection currents surged through that mantle like giant waves, driving the restless motion of the crust above. Even then, before continents and oceans, the seeds of tectonic movement had already begun. Occasionally, the bombardment from space grew quieter. For brief moments, silence covered the surface. The lava cooled into jagged black plains of basalt. Thin crusts formed, only to shatter again when another impact struck. No place was stable. No region remained untouched for long. Comets from the outer solar system occasionally plunged into this inferno, their icy bodies disintegrating on contact, releasing water vapor that rose into the choking atmosphere. For the first time, the Earth began to collect traces of water. But this water could not yet exist as oceans. It remained steam, trapped in the superheated air, waiting for the day when the planet would cool enough to let it fall. As the millions of years crawled on, the bombardment continued, but the intervals between impacts slowly grew longer. The planet began to take a recognizable shape, not yet beautiful, but less chaotic. Volcanic chains rose across the surface, giant mountains of liquid rock that fed the atmosphere with gases. This constant outgassing built up the planet's first stable air, though it was deadly to anything that might one day breathe oxygen. Beneath that poisonous sky, the ground shimmered with heat. Molten rivers carved valleys that glowed in the night. Cracks opened across the crust, releasing fountains of magma and clouds of ash that could darken the horizon for decades. These eruptions covered the surface again and again, layering it in black basalt that cooled into glassy plains. And yet, amid the destruction, order began to form. Within the depths of the mantle, the heat started to circulate more rhythmically. Areas of cooler crust thickened slightly, floating atop the molten sea below. The planet was learning to balance itself. Mountains formed and collapsed, valleys filled with lava, and the first signs of stability appeared fragile, fleeting, but real. Above, the sun was still young and violent. Its radiation bombarded the Earth, stripping away the lighter elements from the atmosphere. But the planet's new magnetic field, generated by its spinning iron core, began to push back. Invisible lines of force wrapped around the globe, deflecting the solar winds. This magnetic shield was the planet's first protector, the silent guardian that would one day allow life to survive. The Hadean Earth was a world of extremes. By day, temperatures soared high enough to melt stone. By night, when the lava cooled and the skies darkened, frost could briefly form on the edges of rock before vanishing in the morning heat. Lightning illuminated the landscape, striking metal-rich ground and vaporizing entire regions into glass. In the distance, the moon hung large, and close far larger in the sky than it appears today. It glowed with a soft, reddish hue, still scarred from its own violent formation. Its gravity tugged at the molten oceans of magma, stirring tides of liquid rock across the surface. the moon's presence slowed the planet's rotation, bringing the first faint rhythm to a world that had known only chaos. Millions of years passed in a slow, fiery blur. The impacts grew rarer, though when they came, they were catastrophic. One final barrage, known as the Late Heavy Bombardment, pounded the planet with asteroids the size of cities. Entire regions melted into new seas of lava. The surface was erased again, reshaped by fire. But the planet endured. Beneath the constant destruction, something permanent was forming. The crust thickened, cooling enough to resist total melting. Volcanoes still erupted, but between eruptions their lava cooled into the earliest stable rocks, the first true record of the Earth's surface. These rocks, now ancient beyond imagination, would one day be found deep within the continents, the last survivors of a world long gone. As volcanic gases escaped from the mantle, the atmosphere grew denser. Steam condensed into clouds. The air was filled with sulfur, methane, and ammonia. No oxygen yet, no blue sky, only a thick orange haze. The greenhouse effect trapped the sun's heat, keeping the surface molten, but slowly reducing the violence of the climate. Eventually, the temperature began to fall. Not enough for life, not even enough for comfort, but enough for water vapor to begin condensing. For the first time, the skies darkened not with ash, but with true clouds of rain, and then it came a downpour like none ever seen again. Boiling rain hammered the surface, hissing as it struck the hot rock, evaporating almost instantly. But it did not stop. For thousands of years, the rain continued, cooling the crust, filling depressions, and carving channels through the black volcanic plains. In time, the water found places to settle, forming the earliest puddles, lakes, and eventually shallow seas. These first waters were not calm or blue. They were acidic, thick with dissolved minerals and metals, but they were enough to begin the slow transformation of the planet's surface. Lava met water, forming steam that rose to feed the clouds, which rained again, an endless cycle of boiling creation. Deep beneath the crust, the core pulsed with heat, iron and nickel swirled in molten motion, driving the magnetic field that reached far into space. That field shielded the planet from radiation, allowing its atmosphere to remain intact while other worlds lost theirs. Venus and Mars would suffer different fates, one choked by heat, the other frozen in silence, but Earth endured between them, balanced by its shield and its distance from the sun. Slowly, the fire began to fade. Continents had not yet formed, but the groundwork was being laid. Patches of thicker crust rose above the seas of lava, forming small landmasses that drifted and collided. Each collision forced molten rock upward, building mountains that would soon erode and collapse back into the fiery depths. The Hadean Earth had no beauty, no green, no sound, but the roar of its volcanoes and the thunder of impacts. Yet it was here, in this nightmare world, that the planet's foundation was built. Its oceans, atmosphere, crust, and core all took shape in this time of chaos. Every element that would one day support life was forged in the violence of these early ages. With every eruption, carbon dioxide filled the air, creating the conditions for warmth. With every storm, minerals washed into the oceans, seeding them with chemistry. With every flash of lightning, energy coursed through the atmosphere, sparking reactions between gases that would produce the first organic molecules. Though life was still far away, the ingredients were gathering. As the bombardment finally slowed and the skies began to clear, the first glimpse of sunlight reached the surface. It broke through the haze like a blade of gold, scattering across dark oceans and black rock. Steam rose in pillars from volcanic islands, catching the light Like ghostly flames, the Earth was cooling, breathing, preparing. In the distance, the moon's reflection shimmered across the surface of the molten seas. The tides it pulled grew weaker as the moon drifted slowly farther away, but its influence remained. Its gravity continued to shape the rhythms of the planet, stabilizing its tilt, moderating its seasons. Without it, the planet's chaos might never have ended. As millions more years passed, the fiery glow of the Hadean began to dim. The crust thickened further, the oceans grew deeper, and the air became dense with carbon and nitrogen. No oxygen yet filled the atmosphere, but the foundation of a stable world was in place. The planet that had been a molten inferno now wore a thin shell of solid rock. Beneath it, heat still surged, driving tectonic forces that would one day move continents and raise mountain ranges. Above it, the storms began to calm, the air cooling enough to allow permanent clouds. The rain that once boiled away now reached the surface, feeding the newborn seas. Earth had survived its most violent chapter. It had endured fire and stone, ice and impact, chaos and collapse. From a storm of cosmic debris, it had become a true planet, scarred, battered, but alive in its own way. And beneath the oceans that now covered much of its surface, strange chemistry was stirring. In the shadows of volcanic vents and the warmth of shallow seas, molecules were beginning to form chains, reacting, splitting, and merging again. The Hadean world, once only destruction, was preparing for creation. This was the crucible of life. And as the fiery ages came to an end, the Earth entered a new era, one where water would dominate, where the first sparks of biology would flicker into existence. The Hadean hell had forged a world capable of harboring miracles. The fire had shaped it. The storms had tested it. The impacts had nearly destroyed it. But in the end, through chaos and heat and unending violence, the Earth had found its balance. And in that balance, the potential for everything that would ever live was born. The world had finally quieted. The skies no longer rained fire, and the oceans no longer boiled from the planet's fury. After hundreds of millions of years of relentless chaos, the Earth had begun to cool enough for calm to exist, at least for moments at a time. The Hadean hell had ended, and something entirely new was about to begin. The crust was solid now, dark and scarred, broken by mountains of basalt and ancient volcanic ridges. Vast oceans stretched across the planet, still tinted green and brown by minerals and acids, but stable enough to endure. Clouds drifted across a thick orange sky, reflecting sunlight that was dimmer than today, for the young sun still burned weaker, giving off only about 70% of its current brightness. Yet the Earth did not freeze. Volcanoes continued to pour out carbon dioxide, creating a greenhouse blanket that trapped enough heat to keep the oceans liquid. This balance between heat and cold, chaos and calm, made something extraordinary possible. The atmosphere, though deadly to anything resembling modern life, was a bubbling cauldron of chemistry. Nitrogen, carbon dioxide, methane, ammonia, and water vapor filled the air. Storms rumbled across the horizon, flashing with lightning that illuminated the dark world below. Each bolt struck the oceans, releasing immense energy that tore molecules apart and allowed new ones to form. In the shallow waters near volcanic islands, pools of rainwater evaporated under the weak sun, concentrating the elements within. Here, carbon mixed with hydrogen, oxygen, and nitrogen, forming simple organic compounds, amino acids, sugars, and fatty molecules. The building blocks of life had appeared, though they were still only lifeless chemistry waiting for a spark of organization. The Earth's oceans were alive, not with creatures, but with reactions. Hydrothermal vents on the seafloor spewed boiling water rich in minerals and metals. These vents, glowing like underwater furnaces, became oases of chemical activity. Iron, sulfur, and carbon combined under high pressure and temperature, forming complex molecules that drifted upward through the dark water. Around each vent, gradients of heat and acidity acted like invisible engines, driving reactions that could form chains of molecules capable of storing and transferring energy. Perhaps it was here, in the deep, where life began not in sunlight, but in darkness, born from the heat of the planet's core. Or perhaps it began in the shallow tidal pools, where rain, sunlight, and evaporation cycled endlessly, concentrating the organic materials into thicker, stickier forms. Whichever path nature chose, it was through chemistry that the first steps toward biology emerged. Somewhere in those early oceans, among countless molecules colliding and breaking apart, something remarkable happened. A chain of molecules formed that could copy itself. This was no life as we know it, but it was the beginning of inheritance, the first time matter carried a pattern that could be repeated. Replication had begun. And with replication came evolution. At first, these primitive molecules were unstable. Most broke apart, destroyed by heat, radiation, or chemical reactions. But a few managed to survive a little longer, long enough to create more copies. Every generation, the survivors changed slightly, improving their stability, becoming more efficient at replication. They competed silently in the ancient seas, driven only by the laws of chemistry and chance. Through these early struggles, the first true biological systems began to appear: tiny, membrane-like structures formed from fatty molecules that enclosed these self-replicating chains. These membranes provided protection, keeping valuable molecules inside and the chaos of the outside world at bay. For the first time, something could be said to live not yet a cell, but a forerunner of one. These proto-cells floated through the ocean, fragile bubbles filled with chemistry. Most perished quickly, but those that survived began to evolve. Within them, chemical networks developed that could harness energy from their surroundings. Perhaps they used heat from hydrothermal vents, or perhaps they absorbed chemical gradients in the water, using them to power their internal reactions. The Earth, once a world of lifeless stone and fire, was now a planet with behavior. Matter had learned how to copy itself, to grow, to survive. And though invisible to the eye, these microscopic pioneers would change everything. The oceans thickened with organic molecules, creating a world sometimes called the primordial soup. From this mixture, countless combinations of atoms assembled and disassembled. Carbon-based chains folded into new shapes, forming primitive enzymes that could speed up reactions. Simple genetic codes began to form, allowing information to be stored and passed on. Millions of years passed in this invisible struggle. Life was fragile, confined to the oceans, hiding from the deadly ultraviolet radiation that scorched the planet's surface. The atmosphere still lacked oxygen and ozone, so only beneath the protection of water could life persist. There, in the dim light of the deep, early microbes adapted, feeding on the chemical energy from vents and minerals. These first organisms were simple, single-celled, and small beyond imagination. Yet, they were the architects of everything to come. They multiplied, spread, and evolved into diverse forms of microscopic life. Some developed the ability to capture energy from sunlight using pigments that absorbed specific wavelengths. This primitive photosynthesis began to change the planet once again. At first, the process did not produce oxygen. Instead, it relied on sulfur compounds, using sunlight to split them apart for energy. But over time, a new form of photosynthesis evolved, one that used water as the source of hydrogen. When water was split, oxygen was released as a byproduct. And with that, the great transformation began. Oxygen, once rare on Earth, started to accumulate in the oceans. At first, it reacted with dissolved iron, forming vast layers of rust that settled on the seafloor, the banded iron formations still found in rocks today. For millions of years, the oceans continued to absorb oxygen, turning from green to a clearer blue. Eventually, the saturation point was reached and oxygen began to escape into the atmosphere. This invisible revolution would one day reshape the entire planet. But for now, it remained a quiet process, unnoticed by the microbes that caused it. Life had taken hold and was beginning to alter the world around it. As more time passed, these single-celled organisms became more complex. Some developed internal structures, membranes within membranes, allowing for greater efficiency and specialization. These would eventually give rise to the eukaryotic cells, the ancestors of all plants and animals. But that was still far in the future. For now, the world belonged to the microbes. They covered every surface, the rocks, the ocean floor, even the layers of sediment forming beneath the sea. They formed colonies that clung together in mats, feeding off sunlight and chemical reactions. As they thrived, they began to shape the planet's geology, chemistry, and atmosphere. Life was now a geological force. The Earth itself began to change in response. The balance of gases in the atmosphere shifted. Volcanic activity released carbon dioxide, while microbes absorbed it. The greenhouse effect fluctuated, creating periods of warming and cooling. Continental fragments moved slowly across the surface, forming and breaking apart as tectonic forces continued their restless motion. The once violent world had settled into cycles day and night, heat and cold, rain and evaporation. Tides, driven by the moon, stirred the shallow waters, mixing nutrients and chemicals. This gentle rhythm created an environment of stability in which life could evolve. And evolve it did. From the first self-replicating molecules to primitive cells capable of harnessing sunlight, the ocean had become a living laboratory. Every drop of water contained millions of microorganisms, each carrying its own version of the genetic story. The competition among them drove the diversity of forms, leading to new metabolic pathways and more efficient ways of surviving. Though unseen, this microscopic revolution laid the foundation for everything that would follow. Without these early organisms, there would be no oxygen, no plants, no animals, no future world of forests, seas, or humans. All of it began here, in the quiet depths of the primordial ocean. The Earth had changed from a world of fire to a world of life. The air above was still harsh, filled with carbon and methane, but beneath the waves, life flourished. The planet, once silent, now hummed with a faint chemical pulse of living processes. The dawn of life was not a single moment, but a slow awakening. Over hundreds of millions of years, chemistry gave rise to biology, and biology began to transform the planet. From simple molecules came replication. From replication came evolution, and from evolution came the first living world. The Earth was no longer alone in its motion. It carried with it something that could grow, change, and think, though that last part was still billions of years away. The story of life had begun. It was fragile, microscopic, and hidden beneath the ocean's surface, but unstoppable. From these beginnings, all future life would descend. Every tree, every animal, every human would carry within their cells the ancient memory of this moment, the time when the Earth first breathed. The planet had emerged from chaos into creation. From lifeless stone and metal came the spark of existence. And in the quiet depths of the early sea, under the dim light of a young sun, life looked upward and began its endless journey. The planet had changed beyond recognition. What was once a molten world of fire had become a world of water, rock, and endless microscopic life. The oceans shimmered under a pale sun, their surfaces broken only by rippling waves and the occasional volcanic island. Beneath them, invisible to any eye, trillions of single-celled organisms drifted in silence. They were the architects of the future, slowly, unknowingly reshaping the planet. The Earth was breathing for the first time, but that breath would come with a price. For hundreds of millions of years, the earliest forms of life had lived in darkness, feeding on chemical energy drawn from the Earth itself. But among them, a few tiny organisms had discovered a new trick, the ability to capture sunlight. They had developed pigments that absorbed energy from the sun and used it to power their growth. This process, photosynthesis, began quietly, deep within the oceans. At first, it was simple. These microbes used hydrogen from sulfur compounds or methane, releasing waste that dissolved harmlessly into the sea. But over time, evolution refined the process. A new kind of microbe appeared, the cyanobacteria. They were small, unremarkable to look at, yet they carried within them one of the most important inventions in the history of life, the ability to split water. By using water as their source of hydrogen, these organisms released oxygen as a byproduct. Oxygen, a gas that, at the time, was deadly to most living things. At first, the oxygen reacted with everything it touched. It combined with iron dissolved in the oceans, forming rust that settled on the seafloor. Layer by layer, these iron-rich sediments built up, creating massive sheets of banded rock that still exist today, silent fossils of the planet's first breath. For millions of years, the oxygen never reached the air. The oceans absorbed it all, reacting with the metals and minerals that filled the waters. But as the cyanobacteria continued to multiply, they began to overwhelm these chemical sinks. The oceans could no longer contain the gas they were producing. Slowly, oxygen began to escape into the atmosphere. The great oxygen revolution had begun. It started subtly, almost invisibly. The skies changed color, turning from orange and brown to a faint bluish hue. The air began to thin, losing methane and gaining oxygen. For many of the organisms that had thrived in the old oxygen-free world, this transformation was catastrophic. Oxygen, though life-giving to us, was poison to them. It destroyed their cells, disrupted their chemistry, and wiped out entire populations. The first great extinction in Earth's history had begun, driven not by fire or impact, but by life itself. Beneath the waves, as countless anaerobic species died off, the cyanobacteria flourished. They formed vast colonies that spread across the oceans, growing in shallow waters near the coasts. Over time, they built strange, rocky structures known as stromatolites, layered formations made of microbial mats that trapped sediment and minerals. Even today, ancient stromatolites can still be found, fossils of the earliest ecosystems. These microbial cities grew for hundreds of millions of years, producing oxygen faster than it could be absorbed. The balance of the atmosphere shifted permanently. For the first time in Earth's history, the air contained free oxygen. With this new element came transformation. The oxygen combined with ultraviolet light from the sun to form ozone, a thin but vital layer high above the planet. This invisible shield began to protect the surface from deadly radiation. Before the ozone, life had been confined to the oceans, hiding from the ultraviolet light that scorched the unprotected surface. Now, for the first time, the planet had a defense. The air was still thin, the oxygen levels still low by modern standards. But it was enough to begin changing everything. The chemical makeup of the atmosphere altered the planet's climate. Methane, a powerful greenhouse gas, was slowly destroyed by oxygen, reducing the planet's heat retention. The Earth began to cool. The first great ice ages began vast frozen epochs that covered much of the planet in ice. From the poles to the equator, the Snowball Earth episodes, as they would later be known, tested life's resilience. But life survived beneath the ice, in pockets of liquid water near hydrothermal vents, and in the warm shallows where sunlight could still reach, the microbes endured. They adapted, finding ways to use oxygen not as a poison, but as a source of power. It was a revolutionary leap. Oxygen, once deadly, became the fuel for more efficient metabolism. Cells that could harness oxygen gained a tremendous advantage, extracting far more energy from their food than their ancestors ever could. From this adaptation, the seeds of complex life were sown. Deep in the oceans, primitive eukaryotic cells began to emerge, organisms that enclosed their genetic material within membranes, forming nuclei. They developed internal structures, each one performing a specific task. Some of these cells formed partnerships with smaller bacteria, which they absorbed but did not digest. These bacteria evolved into mitochondria, tiny powerhouses that provided their hosts with energy from oxygen. This symbiosis changed everything. For the first time, cells could grow larger and more complex. Life was no longer limited to simplicity. While the world above froze, evolution below accelerated. The oceans became laboratories of innovation, where new cellular forms competed and adapted. The Earth, though hostile, was alive in ways it had never been before. The Great Oxygen Revolution did not just change the biology of life, it changed the chemistry and geology of the entire planet. Rocks that had once been blackened by volcanic minerals turned red as iron oxidized. The oceans cleared, their color shifting toward blue, and the atmosphere grew lighter, clearer, and more stable. From space, the transformation was breathtaking. A planet that had once glowed orange and brown now shimmered with white clouds and blue seas. The Earth had taken on the colors we recognize today. This was the planet's second birth. The oxygen, created by countless microscopic organisms, had remade the world. It paved the way for the evolution of complex life, for the rise of plants and animals, and eventually for the oxygen-rich atmosphere we breathe today. But for hundreds of millions of years, it was still a world of microbes, a quiet, unseen realm that built the foundation of everything that would follow. The extinction of the old anaerobic world was nearly total. The microbes that survived did so by retreating to oxygen-free environments deep in the mud, within rocks, or in the absence of sunlight. They still exist today, ancient relics of that first age, reminders of a time when oxygen was the enemy. The survivors that embraced oxygen spread far and wide. They evolved into new forms, filling every niche the planet offered. Each adaptation, each small change, carried the blueprint for future evolution. Over millions of years, the balance of gases stabilized. Carbon dioxide and nitrogen remained dominant, but oxygen levels continued to rise slowly. With the ozone layer forming above and the greenhouse gases moderating below, the planet entered a period of relative calm. Sunlight reached the surface more consistently, and the temperature stabilized enough to prevent another full planetary freeze. The Earth was ready for the next chapter, but the oxygen revolution had lasting consequences. It not only reshaped the chemistry of life, but also influenced the cycles of the planet itself. Carbon, nitrogen, and sulfur began to move through ecosystems in ways they never had before. The interaction between the biosphere and the atmosphere became a feedback loop, life influencing climate and climate influencing life. This intricate balance, once established, would persist for billions of years, and though future events would bring new extinctions and cataclysms, the foundation of oxygenic life would remain unbroken. As time passed, the once lifeless planet became more complex, more dynamic. The oceans teemed with microscopic ecosystems. Currents carried nutrients across the globe, feeding microbial colonies that continued to pump oxygen into the atmosphere. The once toxic gas had become the breath of the planet. And yet, for all its beauty, the world was still quiet. There were no forests, no creatures walking on land, no sound but the waves and the whisper of wind across stone. The Earth was alive, but its story had only just begun. Above, the sky was blue for the first time. Clouds drifted gently across the horizon. The sun shone brighter now, no longer filtered through the thick haze of methane and ash. The air, though still thin and strange, carried the scent of transformation. Beneath that endless sky, the ocean stirred with promise. Life had conquered chemistry, turned poison into power, and reshaped a world. From this invisible triumph, every plant, every animal, every human would someday inherit the same air, the same breath, the same story written in the molecules of oxygen. The great oxygen revolution had ended the first age of life and begun the second. The planet that had once choked on fire and ash now exhaled vitality. From death came adaptation. From poison came power. From chaos came the possibility of everything that would follow. The Earth, for the first time, was truly alive. The Earth turned slower now beneath a pale and distant sun. The air had grown thinner, the light colder. The oceans, once green and teeming with microscopic life, began to darken. The balance that life had created, the fragile equilibrium between carbon dioxide and oxygen, was starting to shift. It began quietly. Volcanic activity slowed, releasing less carbon into the atmosphere at the same time. The newly oxygen-rich air reacted with minerals on land, locking carbon dioxide into stone. With less carbon to trap heat, the planet started to cool. Snow began to fall at the poles. At first, it melted when it reached the equator, but as temperatures continued to drop, it lingered. Ice reflected sunlight back into space, cooling the planet even more. This feedback loop deepened until the transformation was unstoppable. The Earth froze. Ice crept from the poles toward the equator, spreading across continents and seas alike. Glaciers grew hundreds of meters thick, grinding mountains into dust. The oceans began to freeze from the surface down, trapping life beneath sheets of white silence. Even the equatorial regions, once warm and tropical, were buried under frost. The planet had become a frozen sphere, a snowball spinning through the blackness of space. Beneath the ice, the world did not die. In the darkness of the oceans, near hydrothermal vents and volcanic fissures, life persisted. There, in the warmth of the deep, microbial communities continued their ancient cycles, surviving on the heat and chemicals that the planet still offered. But the surface was silent. The winds howled over frozen deserts, carrying ice crystals instead of dust. Volcanoes still erupted occasionally, sending plumes of ash into the air. But even their fury was muffled by the cold. Sunlight struggled to pierce the haze, and when it did, it reflected off the endless white, offering no warmth. For millions of years, this icy grip held the planet captive. The Earth had frozen before, but never like this. This was not a season or a storm, it was an age. The oceans beneath the ice remained liquid in places, warmed by geothermal heat. Life retreated there, clinging to survival. These isolated refuges became the last sanctuaries of biology on the planet. Cyanobacteria continued their slow work, photosynthesizing where faint light could still reach through thin ice. Others lived near the vents, feeding on minerals and gases. In these hidden oases, evolution did not stop. It simply slowed, waiting for the planet to awaken. But nature's balance never holds forever. Beneath the frozen crust, volcanoes began to stir once again. Trapped carbon dioxide from the planet's interior started to escape, building up in the atmosphere. For millions of years, the gas accumulated, unable to dissolve into the frozen oceans. The greenhouse effect grew stronger with every eruption, and slowly the planet began to warm. As temperatures rose, the ice began to melt, at first only near the equator, where sunlight was strongest. Vast sheets of ice cracked and splintered, revealing dark ocean water beneath. That dark surface absorbed heat instead of reflecting it, accelerating the thaw. A chain reaction began, unstoppable once it started. Within a few thousand years, a blink in geological time, the Snowball Earth melted. Floods of meltwater roared across the continents. The atmosphere, thick with carbon dioxide, trapped immense heat, turning the planet from a frozen tomb into a steamy greenhouse. Temperatures soared. Massive storms swept across the world, eroding mountains and reshaping rivers. Life, long confined to its icy prisons, was free once again. The oceans, now filled with nutrients from the melted ice and eroded rock, exploded with biological activity. Cyanobacteria flourished, producing oxygen at unprecedented rates. Other microbes evolved new ways to survive in the changing environment, feeding on minerals and sunlight alike. The Great Thaw had not only revived the planet, but set the stage for evolution to accelerate. New environmental pressures, from extreme cold to extreme heat, forced life to adapt or perish. And from those survivors, new forms would emerge. The aftermath of Snowball Earth was a world of extremes. The ice had scoured the continents bare, leaving behind vast plains of rock. Erosion carried minerals into the oceans, enriching them with nutrients that fueled microbial blooms. Oxygen levels in the atmosphere continued to rise, further transforming the chemistry of the air and water. The sky, once dim and grey, turned a deep, rich blue. Sunlight poured through the clearing atmosphere, illuminating oceans that now shimmered with life. From space, the planet was reborn, vibrant and alive, its white scars fading into memory. But the memory of the ice lingered. Life had learned resilience in its darkest age. It had learned to survive in boiling heat and frozen depths, to adapt to scarcity and abundance alike. These lessons would echo through evolution, preparing life for every challenge yet to come. As the climate stabilized, the continents began to move once more. Tectonic forces pushed land masses together, forming supercontinents that drifted across the surface. Volcanic eruptions released fresh carbon dioxide, balancing the atmosphere and preventing another deep freeze. In this renewed stability, something extraordinary happened. Cells began to cooperate. For billions of years, life had remained single-celled tiny organisms living and dying alone. But now, under the new conditions, some cells began to join together, forming colonies. At first, these were simple arrangements, clusters of identical cells sharing nutrients. But over time, specialization appeared. Some cells took on specific roles, gathering food, providing structure, reproducing. Multicellularity had begun. This new way of life allowed organisms to grow larger, more efficient, and more adaptable. Instead of competing as individuals, they functioned as parts of a greater whole. The evolution of multicellular life was one of the most significant transitions in the history of the planet, and it was made possible by the trials of Snowball Earth. With more oxygen available and more stable climates, evolution accelerated. New forms of algae appeared in the oceans, feeding on sunlight and releasing even more oxygen. The cycles of energy and matter grew more intricate. The planet, once nearly dead, had become a living engine. Still, the scars of the ice remain visible in the rock's grooves, carved by glaciers, sediments deposited by melting water, and minerals that only form under extreme cold. These geological memories tell the story of how close the planet came to losing everything and how life endured through it all. The Earth was resilient but delicate. The balance between carbon, oxygen, and temperature was fragile, always on the edge of change. It was a system that required constant motion. Volcanoes to release gases, oceans to absorb them, life to regulate their exchange. This balance, forged through disaster, would sustain the planet for billions of years more. As the snow and ice retreated, new coastlines appeared. Shallow seas spread across the continents, creating vast marine habitats. Sunlight penetrated these warm, nutrient-rich waters, fueling explosive growth. Plankton, algae, and cyanobacteria formed dense layers near the surface, creating the first true ecosystems. Oxygen filled the oceans, transforming them from green to blue. Iron, once dissolved in abundance, now oxidized and settled to the sea floor. The chemistry of the planet had changed once again, this time permanently. And as life expanded, it became more diverse. Evolution, no longer constrained by survival alone, began to explore form and complexity. Organisms learned to sense, to move, to respond to their environment in new ways. Beneath the calm surface of the oceans, the groundwork for the next great revolution was being laid, the explosion of animal life that would soon follow. But before that dawn, the planet took a breath. The ice had retreated, the heat had calmed, and the world stood at peace for the first time in eons. The sky glowed with the soft light of a maturing sun, and the continents shimmered with rivers that flowed through fresh valleys. The Earth had endured catastrophe and emerged stronger. It had learned balance through chaos, harmony through destruction. From a frozen world came renewal. From extinction came evolution. The Snowball Earth had tested the limits of life and found them vast. And when the ice melted, life did not merely return, it conquered. The planet was no longer silent. After billions of years of simplicity, the oceans had begun to stir with a new kind of movement, fast, deliberate, and alive. Tiny ripples danced beneath the waves as creatures with soft bodies wriggled and crawled through the mud. The world, once ruled by invisible microbes, was about to change forever. The Cambrian age had arrived. For most of Earth's history, life had existed only as single cells or simple colonies, too small to see, too quiet to notice. But now, evolution surged forward in a burst of creativity unlike anything before. Within only a few tens of millions of years, a brief moment in geological time, nearly every major body plan that would ever exist appeared in the oceans. It was the greatest explosion of life the planet had ever seen. Beneath the waves, the seafloor became a crowded battlefield. Trilobites, armored like living shields, crawled along the sediment, searching for food. Above them, worm-like creatures burrowed, hiding from predators that hunted by smell and vibration. Spiny, tentacled animals filtered particles from the water, while strange jellyfish-like forms drifted through the currents, their transparent bodies glowing faintly in the dim light. For the first time in history, life had developed eyes. Tiny spots of light-sensitive cells evolved on the bodies of early animals, allowing them to detect shadows and motion. Sight transformed the oceans. Suddenly, the difference between life and death depended on who could see first. Predators became more efficient, and prey learned to hide, burrow, or camouflage. Evolution accelerated in response, each adaptation giving rise to another. Shells and exoskeletons began to appear hard defenses made of calcium carbonate that protected fragile bodies from attack. With shells came fossils, the first permanent record of complex life. What had once been a world without memory now began to write its history in stone. The oceans were alive with color and movement. Forests of sponge-like organisms grew from the seabed, filtering nutrients from the water. Coral-like colonies began to form, creating the first reefs. Worms tunneled through the mud, mixing oxygen into the sediment and transforming the chemistry of the ocean floor. Life was not only multiplying, it was engineering its environment. In the shallows, algae and cyanobacteria covered rocks, producing oxygen that filled the water and air. This abundance of oxygen fueled the evolution of larger, more active creatures. Muscles became stronger, movements faster, senses sharper. For the first time, life could chase, flee, and fight. Predation changed everything. It forced organisms to adapt in new directions: armor, speed, stealth, and intelligence. The arms race between hunter and prey became the engine of evolution. Some creatures developed sharp claws or spikes. Others grew flexible bodies capable of twisting and darting away. Some burrowed deep into the sand to escape, while others swam higher into open water. This dynamic tension filled every corner of the ocean with diversity. Among the new arrivals were the ancestors of almost every modern animal group: arthropods, mollusks, annelids, and early chordates. Tiny fish-like creatures with primitive backbones began to appear, swimming gracefully through the currents. They were small and fragile, but they carried within them the blueprint for all vertebrate life to come. The oceans, once still and quiet, now echoed with the rhythms of feeding and escape. Microscopic plankton drifted in massive clouds, feeding larger filter feeders that swept them up with gaping mouths. Early predators like Anomalocaris, with its circular jaws and grasping limbs, ruled the seas, capable of swallowing creatures half its size in a single strike. The Cambrian world was a place of wonders and nightmares. Its creatures were both alien and familiar. The first experimentations of evolution, testing what life could become. Sunlight streamed through the water, illuminating the coral-like structures and soft fields of algae. Beneath them, the seafloor shimmered with color, reds, greens, and golds from mineral-rich sediments. It was a world bursting with variety, energy, and motion. And yet, it was fragile. The balance of oxygen, carbon, and nutrients was delicate. Small shifts in climate or volcanic activity could disrupt ecosystems, wiping out entire species. But extinction only made room for more innovation. Each collapse was followed by new adaptations, new life forms, better suited to the changing world. The Cambrian explosion was not a single event, but a chain reaction, one that lasted tens of millions of years. Each evolutionary leap opened possibilities for the next, creating an accelerating cycle of diversity. The development of nervous systems and sensory organs allowed creatures to interact with their surroundings in unprecedented ways. They could feel, sense, and react, and behavior became a new dimension of survival. The first ecological networks appeared: predator, prey, scavenger, and decomposer, each role connected to the others in a web of life. For the first time, energy flowed through the biosphere in complex cycles, from sunlight to plant-like organisms to animals. The Earth had become a living machine. The continents during this time were mostly barren. No plants yet grew on land. No animals crawled across the rocks. The land was a silent desert of stone and sand, battered by wind and rain. But the oceans were alive, their surfaces shimmering with microbial films that trapped sunlight and released oxygen. Storms swept across the seas, stirring nutrients from the deep to the surface. Each wave carried the potential for new life, each droplet filled with microscopic organisms. Beneath the calm blue of the ocean's surface, the struggle never ceased. Trilobites clashed in feeding frenzies. Worms burrowed to safety, and predators glided silently, waiting for movement. Life had discovered complexity, and with it came competition, cooperation, and even the earliest forms of communication, chemical signals that allowed organisms to sense danger, find mates, or claim territory. The Cambrian explosion also gave rise to symmetry, the organized structure of body plans that made movement and balance possible. Bilateral symmetry, with distinct fronts and backs, left and right sides, allowed creatures to move with purpose. Evolution favored this design, and it became the foundation for most animal life that followed. In the depths, some species evolved to survive in darkness, feeding on detritus falling from above. Others, near the light, grew transparent or reflective skins to hide from predators. Life was inventing strategy, learning to manipulate the environment to its advantage. Over millions of years, the diversity became staggering. More species lived in the Cambrian oceans than had ever existed before. The fossil record from this era, preserved in places like the Burgess Shale, reveals a world of endless creativity, creatures with feathery limbs, spiked bodies, and unimaginable forms. Each one was a new experiment in survival. As life grew more complex, ecosystems stabilized, food chains formed, energy cycled through producers, consumers, and decomposers. For the first time, the planet had a self-sustaining biosphere. The oxygen levels in the atmosphere continued to rise, feeding the fires of evolution with more energy available. Organisms could afford to grow larger, move faster, and develop specialized organs. Vision, smell, and touch became powerful tools. The Cambrian explosion was not just the birth of animals, it was the birth of complexity itself. From simplicity came structure. From chaos came order. The oceans glowed with vitality, a world in constant motion. Every ripple, every shadow, every breath of current carried life. Predators chased prey through coral forests, and tiny organisms formed the invisible backbone of the food web. And somewhere, hidden in those waters, the ancestors of all future species, swam creatures whose descendants would one day crawl onto land, take to the skies, and walk under open skies. The Earth, for the first time, was truly alive in every sense, not just chemically, but behaviorally, ecologically, and emotionally. The Cambrian world was alive with purpose, with hunger, with fear, with growth. And though extinction would claim many of these first pioneers, their legacy would never fade. Every creature to come fish, amphibian, reptile, mammal, human, would carry within its body the blueprint first written in the Cambrian seas. Life had found its rhythm, and from this symphony of evolution, the next great chapter was waiting the moment when life would rise from the water and claim the land. The The Cambrian explosion had set the stage. The ocean had done its part. The next step would change the planet forever. For billions of years, the oceans had been the only home for life. Every living thing, from the simplest bacteria to the strangest Cambrian creatures, had lived, fed, and died beneath the waves. The land was silent, barren, and lifeless. A wasteland of rock and dust beneath an empty sky. But that was about to change. Slowly, life began to push beyond the water's edge. It started in the shallow places, where the tide ebbed and flowed, leaving pools of water that warmed in the sunlight. Here, tiny green algae clung to wet rocks, absorbing carbon dioxide from the air and sunlight from above. They grew, spread, and learned to survive brief moments of dryness before the next wave returned. These fragile pioneers were the first to test the world beyond the sea. Over millions of years, algae evolved into the first true plants. They developed tougher cell walls, waxy coatings to prevent drying, and roots to anchor themselves in mud. Moss-like plants spread across coastal plains, forming carpets of green where once there had been only stone. The world was transforming. The air, once thick with carbon dioxide, began to change as plants absorbed it and released oxygen. Each breath of wind carried the scent of new life, though no creature yet existed to notice it. Soon, the green spread further inland. Small rivers and floodplains became oases of primitive vegetation. With plants came soil. As roots broke down rocks and dead plant matter began to accumulate, the surface of the planet softened. The continents, once lifeless, began to breathe. But the conquest of land was not without its challenges. The sun burned brighter on the open surface, and without the protection of water, ultraviolet radiation was deadly. Plants adapted by developing protective pigments and thicker outer layers. They grew taller, competing for light, and began to form the first vascular systems tubes that carried water and nutrients from root to stem. This innovation changed everything. Plants could now grow larger and survive farther from the coasts. Forests began to take shape, filled with towering ferns and strange, leafless trees. The barren land was becoming green, and with it came the first stable ecosystems on land. The transformation of the continents created new opportunities. The soil was rich with nutrients, and decaying plants formed layers of organic matter that held moisture. The stage was set for animals to follow. The first to venture onto land were not explorers in the human sense, but accidental travelers. Small arthropods, ancestors of insects and crabs, crept from the shallow waters onto damp sand, searching for food among the decaying plants. Their hard exoskeletons protected them from drying out, and their jointed legs allowed them to crawl across uneven surfaces. At first, they could only survive briefly before retreating to the sea. But evolution is patient. Some arthropods developed specialized breathing structures that could function in air. They lingered longer, hunting smaller creatures and feeding on decomposing plants. Over time, they became true land dwellers, the first terrestrial animals. The land was no longer silent. Tiny creatures scurried through the undergrowth of early mosses and ferns. Millipedes and centipedes crawled across the soil, feeding on decaying vegetation. The first spiders appeared, spinning silk to trap prey that ventured too close. Insects, small and wingless at first, became masters of this new world, adapting to every niche. Meanwhile, the oceans continued to thrive. Coral reefs expanded, and fish evolved into new forms. Some grew jaws, a simple but revolutionary change that allowed them to bite and chew rather than simply filter food. With jaws came dominance. The first true predators of the sea emerged armored fish with bone-plated heads and mouths full of teeth. Among them were the ancestors of all vertebrates that would one day walk the earth. In shallow coastal waters, some fish began to adapt to life near the shore. They developed stronger fins that could push them through muddy bottoms or help them move between pools when the tide went out. Some even began to gulp air from the surface, using modified swim bladders as primitive lungs. These early fish, known as lobe-finned fish, were the bridge between two worlds. In time, they gave rise to the first amphibians, creatures that could breathe both in water and on land. Their fins evolved into limbs capable of supporting their bodies. They could drag themselves across mudflats, seeking new pools when the water dried up. It was an awkward transition. Their movements were clumsy, their skin fragile, their survival uncertain. But evolution rewarded persistence. Each generation grew stronger, more capable, more adapted to the new environment. The age of land had begun. Forests spread across the continents, growing denser and taller. The air filled with oxygen, produced in abundance by the vast greenery. The climate stabilized, with rain cycles driven by the evaporation from endless forests, rivers carved valleys, and fertile plains formed where floods brought nutrient-rich sediments. For the first time in history, the land became a self-sustaining ecosystem. Amphibians flourished in this new world. They laid their eggs in water, but spent much of their lives on land, hunting insects and other small creatures. With time, they grew larger and more diverse. Some returned to the water as full-time predators. Others ventured deeper inland, away from their aquatic origins. These pioneers paved the way for reptiles, creatures that would one day dominate the earth. But in this age, amphibians ruled, giant salamander-like beasts prowling swamps, feeding on anything smaller than themselves. The landscapes of the Devonian period, the age of fish, were lush and humid. Rivers wound through fern forests, and the air shimmered with mist. Dragonflies the size of birds flitted among the plants, and the ground crawled with life. Life had not just conquered land, it had begun to shape it. Plants altered the composition of the atmosphere, stabilizing temperatures and increasing oxygen levels to their highest point in geological history. Insects and arthropods grew enormous in response, their bodies sustained by the abundance of oxygen. The world was vibrant, thriving, and full of promise. But, as always, balance would not last forever. Volcanic eruptions released massive amounts of carbon dioxide, disrupting the climate. Oxygen levels dropped and temperatures fluctuated wildly. Ocean currents changed, triggering extinctions among marine species. Coral reefs vanished, and many of the armored fish that had ruled the seas disappeared. On land, however, life endured. Forests expanded, anchoring the soil and regulating the climate once more. Amphibians survived the chaos, adapting to the new world that emerged from it. From these survivors, evolution would soon craft something entirely new: creatures that no longer depended on water to reproduce. Eggs would gain protective shells, allowing them to survive on dry land. Lungs would grow stronger, skin thicker. Life would no longer be bound to the oceans. But that transformation lay in the future. For now, the Earth was a paradise of swamps, forests, and rivers. A world alive in every direction. The air was heavy with moisture and the scent of vegetation. The ground pulsed with the movement of insects and amphibians. Thunder rolled across the horizon as storms fed the endless cycle of rain and growth. From space, the planet glowed green and blue, alive with oxygen and motion. The transformation from barren rock to living world was complete. It had taken billions of years for life to rise from the ocean's depths to claim the land, but it had done so with unshakable persistence. The Earth had once been a planet of fire, then of ice, and then of water. Now it was a world of forests. And from those forests, the next great age would soon rise, the age of giants, when creatures would grow larger, ecosystems would deepen, and the planet would experience its first true reign of abundance. But for now, the land had just begun to breathe. The conquest was complete, and the world, for the first time, echoed with the sound of wind through leaves and the quiet steps of creatures walking on solid ground. The world had turned green. Vast forests blanketed the continents, stretching from horizon to horizon. The air was thick with mist and the scent of wet soil. Towering trees rose from the ground like living pillars, their trunks wrapped in ferns and moss. Sunlight filtered through dense canopies, casting the swamps below in an eternal twilight. This was the Carboniferous period, an age when Earth became a living, breathing machine. The land that had once been barren stone was now a humid paradise. Rivers wound through tangled jungles, feeding endless wetlands. Rain fell almost constantly, keeping the air warm and damp. Everywhere there was life, a green explosion that reshaped the planet. The forests were dominated by giant plants, unlike anything alive today. Towering lycophytes and horsetails grew over 30 meters tall, their bark covered in scales, their roots spreading like vast networks through the mud. Beneath them, ferns and seed ferns formed dense carpets, while fungi thrived in the perpetual moisture. The oxygen levels soared higher than ever before, nearly double those of today. The air itself was fuel, feeding fire and life alike. Every breath carried energy. Every leaf exhaled oxygen into the sky. The atmosphere shimmered with vitality, and with that oxygen came giants. Insects, once small and fragile, grew to monstrous sizes. Dragonflies with wingspans the length of a hawk soared through the humid air, their eyes reflecting green light as they hunted smaller prey. Millipedes thicker than a human arm crawled across the forest floor, feeding on decaying plants. Centipedes, their bodies armored in black plates, moved silently through the undergrowth, waiting to ambush. The world was alien yet familiar, a planet ruled not by mammals or reptiles, but by insects and amphibians. Beneath the canopy, amphibians thrived in the endless swamps. They grew large, some over 2 meters long, with wide mouths and muscular bodies built for hunting, fish, and smaller creatures. Their croaks echoed across the wetlands like deep, resonant calls. They were the masters of the murky waters. Their eggs laid in the calm shallows, their young born as tadpoles before growing into air-breathing adults. The forests themselves were living engines, capturing sunlight and storing carbon deep in their tissues. When these trees died, they fell into the swampy mud where oxygen was scarce. They did not fully decay. Layer upon layer of dead vegetation built up over millions of years, compressed by the weight of time and sediment. These layers would one day become the coal that powered human civilization, a gift from a world long gone. But the creatures of this era knew nothing of the future. They lived and hunted and thrived in a world of warmth and abundance. The swamps buzzed with the hum of insects. Giant cockroaches scuttled across the ground, their wings glinting in the dim light. Spiders, some as large as a human hand, built webs that stretched between ferns. The air was thick with the calls of amphibians, the rustle of wings, the splash of predators moving through the water. Everywhere there was movement, sound, and life. The land had found its rhythm. The carbon cycle between plants, animals, and the atmosphere kept the planet stable. Oxygen fed life, carbon fed the plants. Every fallen tree, every decaying leaf played a part in the balance. Yet, within this balance, evolution continued to work quietly, shaping new possibilities. Among the amphibians, some began to change. They developed thicker skin that resisted drying, lungs that could draw more oxygen from the air, and eggs that could survive without being submerged in water. These small changes gave rise to a new lineage, the first reptiles. With their scaly skin and hard-shelled eggs, these creatures could venture farther inland, free from the need for water. They were small at first, blending into the shadows of the forest floor, but they carried the future within them. These early reptiles would one day give rise to the dinosaurs, the mammals, and eventually the humans, who would rediscover their distant origins in stone. For now, though, the amphibians remained the rulers of the swamps. Their dominance was complete, their reign secure, but the world around them was slowly preparing for change. The lush forests, while beautiful, were also unstable. Their rapid growth pulled immense amounts of carbon dioxide from the atmosphere, lowering global temperatures. As the carbon levels fell, the climate began to cool. Rainfall decreased, and the once humid swamps started to dry. The balance that had sustained this world of giants began to crack. Forest fires became more frequent, fueled by the high oxygen content. Flames raced through the undergrowth, consuming vast areas of vegetation. When the fires died, the land was left bare, the air thick with ash. The great trees that had ruled for millions of years began to vanish. As the climate continued to shift, the continents drifted closer together, forming massive landmasses that altered ocean currents. Deserts began to spread across the interior regions, breaking the dominance of the swamps. The golden age of Carboniferous forests was coming to an end, but in their decline, they left behind something profound, the foundation for future life. The dead forests buried beneath mud and sediment became vast deposits of coal, trapping ancient carbon that would remain locked underground for hundreds of millions of years. The oxygen-rich atmosphere they created would fuel new waves of evolution, and the reptiles, born from amphibian ancestors, were ready to take advantage of the changing world. As the swamps retreated, these early reptiles thrived in the drier environments. Their eggs could survive in arid conditions, their bodies more resistant to dehydration. They were smaller than their amphibian relatives, but faster, smarter, and more adaptable. They spread across the continents, filling niches left empty by the shrinking forests. The age of amphibians was ending, and the age of reptiles was beginning. Still, in some corners of the world, the old swamps endured a little longer. In the misty valleys and lowlands, the last of the great lycophyte trees stood tall, their roots gripping the muddy ground. Dragonflies still drifted through the warm air, and the calls of amphibians still echoed in the night. It was a fading paradise, a memory of an age when the world was a green labyrinth of life. Above it all, the sky glowed golden as the sun set through the haze of moisture and smoke. Lightning flashed on the horizon, illuminating the silhouettes of towering trees and flying insects. The planet was changing, but it still pulsed with vitality. The Carboniferous period was both an ending and a beginning, the culmination of one age and the quiet birth of another. It was a time when the Earth learned to breathe deeply, to store energy for the future, and to prepare for new kinds of life that would reshape everything again. From the decay of forests came the seeds of transformation. From the swamps came evolution, and from the creatures that crawled through those shadows came the ancestors of empires yet to exist. The world had entered its first true golden age of abundance. and though it would not last, its legacy would echo for eons. The coal formed in these swamps would one day burn in furnaces, drive machines, and light the nights of a species not yet imagined. But for now, in the warm twilight of the Carboniferous, the Earth belonged to the forests, the insects, and the amphibians. Giant dragonflies glided through the still air, their wings catching the fading light. Frogs called from the edges of shallow pools. Trees exhaled oxygen into the sky as the stars began to emerge through the mist. It was a world of breath and sound and green, the lungs of the planet expanding for the first time. And as the last light of the day shimmered on the water, the Earth turned slowly toward its next chapter. A world where the green would fade, the deserts would rise, and the reptiles would inherit the land. The world had changed once again. The great swamps of the Carboniferous had vanished, leaving behind dry plains and deserts. The endless rain had stopped, the humid air replaced by arid winds. The continents, once scattered across the globe, were slowly colliding, drawn together by the restless motion of the planet's crust. In time, they merged into a single, massive supercontinent, Panjia. It stretched from pole to pole, a colossal expanse of land, where once there had been scattered islands and shallow seas. Mountain ranges rose where continents met, their peaks slicing through clouds. Vast deserts spread across the interior, their sands shimmering under a relentless sun. Around the coasts, shallow seas and river deltas still supported life, but the heart of Panjia was harsh and unforgiving. The age of reptiles had begun. Their ancestors had crawled out of the swamps millions of years earlier, small and unnoticed, but now they ruled the land. Where amphibians had once dominated the wetlands, reptiles now thrived in the dry heat of Panjia. Their scaly skin protected them from water loss, and their eggs, encased in tough, leathery shells, could survive on land without drying out. These adaptations gave them freedom. They no longer depended on the sea or the swamp. They could live anywhere, in forests, deserts, or plains. They were the masters of the new world. Some reptiles remained small, quick, and agile, darting between rocks in search of insects. Others grew large, developing thick limbs and massive jaws. The landscape was alive with their presence, a planet reshaped by evolution to suit their kind. One of the most dominant groups were the synapsids, reptile-like creatures that would one day give rise to mammals. They were intelligent hunters, their bodies warm and muscular, their teeth sharp and specialized. Among them was Dimetrodon, a predator that stalked the hot plains of Panjia, its back adorned with a tall, sail-like fin used to regulate body temperature. When the sun rose, it basked in the light, absorbing warmth. When the heat grew unbearable, it turned sideways, reducing exposure. It was both reptile and prototype for the warm-blooded creatures that would follow. Dimetrodon ruled the river sides, hunting amphibians, fish, and smaller reptiles. Its world was one of extremes, scorching days, freezing nights, and storms that rolled across the deserts with thunder and dust. Beneath the burning sky, forests still clung to the wetter regions near the coasts. Here, giant conifers and seed ferns formed green havens amid the desolation. Smaller reptiles fed on plants, while predators hunted them from the shadows. Life was adapting to every niche, every climate, every challenge. But Panjia was not kind. Its vast size created violent weather. Monsoon rains drenched one side of the continent, while the other remained bone dry. Inland regions were deserts, lifeless except for a few hardy creatures that could survive weeks without water. The planet's interior baked under the sun, while the poles endured icy cold. Extremes defined the Permian Age. And yet, life flourished. Beneath the surface of the seas that surrounded Panjia, the oceans were alive with strange and diverse creatures. Ammonites drifted through the water in spiral shells, their tentacles reaching out to catch prey. Trilobites, survivors of ancient times, still crawled along the seafloor, though their dominance was fading. Coral reefs thrived in the warm, shallow waters, building massive underwater cities teeming with fish and invertebrates. On land, the ecosystems grew more complex. Plants evolved to withstand dry conditions. Early conifers and seed-bearing trees spread across the continents, creating forests that could survive droughts. As the vegetation adapted, so did the animals. Herbivorous reptiles developed stronger jaws and teeth for grinding tough plants. Predators grew faster and more intelligent to hunt them. Evolution was accelerating, driven by the challenges of this harsh new world. Beneath the surface, the planet itself was changing. Massive volcanic systems stirred deep within the Earth's mantle. Pressure built along the cracks and seams of Pangaea, setting the stage for catastrophe. But for now, the land was alive with the hum of a thriving biosphere. The air, though dry, was filled with the sounds of insects and reptiles. Rivers cut through canyons of red stone, carving paths toward the distant seas. Storms gathered on the horizon, rolling across the plains with lightning that split the sky. It was a world of giants and survivors. In the forests, herbivorous reptiles fed on the tough needles of conifers. Small, agile creatures scurried among the roots, laying eggs in hidden nests. Predators stalked them silently, their eyes keen and their movements calculated. The balance of life and death played out across the endless expanse of Pangaea, a continent large enough to hold every drama imaginable. But this balance was fragile. Beneath the beauty of the Permian world, forces of destruction were already gathering. Deep beneath Siberia, the Earth's crust began to crack open. Fissures released torrents of lava covering millions of square kilometers in molten rock. Volcanoes erupted for centuries without pause, pouring gases into the atmosphere. Carbon dioxide and sulfur filled the air, creating a toxic veil around the planet. Acid rain fell, burning forests and poisoning rivers. The oceans absorbed the gases, becoming acidic and suffocating the life within them. Oxygen levels in both the sea and sky began to drop. The climate spiraled into chaos. Temperatures soared as greenhouse gases trapped heat, while darkness from volcanic ash blocked sunlight. Crops failed, plants withered, and ecosystems collapsed. The chain reaction was unstoppable. The Great Dying had begun. Within a few million years, a blink in geological time, more than 90% of all species vanished. The oceans, once vibrant with coral reefs and fish, turned into lifeless abysses. On land, forests burned, deserts spread, and the last of the great amphibians disappeared. Even the mighty Dimetrodon, master of the Permian plains, fell to extinction. Earth had suffered extinctions before, but none like this. This was not just a loss of life, it was a reset. The biosphere itself nearly collapsed. And yet, even in the ashes of disaster, life endured deep in the oceans. A few hardy species survived in oxygen-poor waters. Small reptiles and insect species clung to life in the least affected regions. From these survivors, evolution would one day rebuild the planet. When the volcanic fury finally subsided, the world was quiet again. The skies cleared, the oceans calmed, and the Earth began to heal. The surviving species spread slowly, reclaiming the land and sea. But the age of the synapsids, the mammal-like reptiles, was over. Their dominance had ended with the Great Dying. In their place, a new lineage began to rise, one that would shape the next era of life on Earth. As Pangaea began to break apart, the first true dinosaurs were waiting in the wings. The Permian Age had given the world its first great empire of reptiles and had ended it in fire. It was a story of adaptation, dominance, and extinction, a reminder that even the mightiest creatures are subject to the whims of the planet they inhabit. And as the Earth turned beneath a recovering sun, the survivors of the Permian looked out upon a world cleansed by catastrophe, a world ready for rebirth. The next age would not belong to the old rulers, but to new giants that would rise from their ashes. And from that rebirth, the world would enter its most legendary chapter, the age of the dinosaurs. The end began slowly, almost invisibly. The Earth looked peaceful. Blue skies, green forests, and calm oceans stretched across Pangaea. But deep beneath the surface, something was stirring. Pressure was building in the planet's mantle, heat rising like breath beneath the skin of the world. Then, the Earth exhaled fire. It started in Siberia, a region that would soon become the furnace of extinction. Cracks split open in the crust, releasing torrents of molten rock. Volcanoes erupted in an unbroken wave, one after another, for hundreds of thousands of years. Lava flooded the land, covering millions of square kilometers in black basalt. The eruptions were not explosive bursts, but slow, relentless outpourings of molten death. With each eruption came clouds of carbon dioxide, methane, and sulfur dioxide. These gases filled the atmosphere, thickening it into a poisonous shroud. Sulfur mixed with water vapor to form acid rain that fell for centuries, corroding rock, killing plants, and poisoning rivers. At first, life tried to endure. Forests that had once thrived in the warm climate began to wilt under the acid rain. The soil grew barren. As vegetation died, erosion stripped the land, filling the rivers and seas with silt. Oxygen levels in the atmosphere began to drop. But the real devastation was yet to come. Carbon dioxide trapped heat in the atmosphere, raising global temperatures by more than 10 degrees. The oceans absorbed much of this gas, becoming acidic and suffocating. Coral reefs, once vibrant underwater metropolises, dissolved into skeletons of chalk. The balance of carbon and oxygen, maintained for millions of years, collapsed. The oceans began to die. As temperatures rose, ocean currents slowed and then stopped. Without circulation, oxygen no longer reached the deep waters. Entire layers of the sea became anoxic dead zones where nothing could survive. Methane-producing bacteria thrived in these oxygen-starved depths, releasing massive amounts of methane into the atmosphere. Amplifying the greenhouse effect even further, the planet spiraled into chaos. Temperatures soared to levels unseen before or since. In some regions, the heat reached over 60 degrees Celsius. The air grew heavy, suffocating. Life on land gasped beneath a crimson sky. Animals collapsed in the heat, forests caught fire spontaneously, ash drifted across continents, turning day into a dull red haze. Insects, the most resilient creatures on Earth, began to vanish. Amphibians, once abundant in the swamps, perished in droves. Reptiles, the rulers of the land, fell one by one. Even the oceans, which had once sheltered life through every previous catastrophe, became tombs. Entire ecosystems collapsed, food chains broke apart. Plankton, the base of the marine web, disappeared, starving the creatures above. Ammonites and trilobites, survivors of countless ages, finally vanished. This was not just extinction, it was annihilation. 95% of all marine species, 70% of land species, gone. Forests disappeared almost entirely, leaving behind a barren landscape of ash and stone. The Earth, for the first time in hundreds of millions of years, was nearly silent. The Great Dying had stripped the planet bare. But even in destruction, the planet was not dead, only changing. As the volcanic activity finally began to wane, the air cleared slightly. Sunlight reached the surface once more, though the heat remained. The oceans, though poisoned, began to recover as new chemical balances slowly formed. Deep-sea vents continued to release heat and minerals, providing sanctuaries for microbial life. In those hidden places, life endured. And where there is life, there is hope. Tiny organisms adapted to the new world. Some evolved to tolerate high temperatures, others to survive in toxic conditions. Evolution, though battered, never stopped working. From these few survivors, the seeds of recovery began to grow. It would take millions of years for the planet to heal. In the aftermath, strange new landscapes emerged. The continents of Pangaea were scorched and cracked. Deserts spread across its center, while coastlines were reshaped by rising and falling seas. Rivers carried the ashes of ancient forests into the oceans, burying the remains of the old world. And slowly, new species appeared. Small, lizard-like reptiles began to populate the land again. They were survivors, tough, adaptable, and resilient. In the oceans, new types of shellfish and coral started to evolve, rebuilding the ecosystems that had collapsed. The atmosphere stabilized as volcanic gases dispersed and the climate cooled to tolerable levels. The Earth had entered a new chapter. The extinction had reset evolution. Those that survived inherited an empty world, a blank canvas, ready to be repainted by life. It was from this devastation that the age of the dinosaurs would rise. But before their reign, the Earth remained quiet for a time. Millions of years passed with little change. Recovery was slow, uncertain, and fragile. Ecosystems took shape only to collapse again. The scars of the Great Dying were deep. The very chemistry of the oceans remained unstable, the oxygen content of the air still low. Even the rocks carried its memory layers of black shale formed in anoxic seas, and ash deposits buried in the continents marked the horizon between life and death. Scientists would one day call it the Permian-Triassic boundary, a line in stone dividing two worlds, the one before and the one after. The world before had been filled with forests, amphibians, and the great synapsid predators. The world after was stranger, quieter, and ready for something new, and the survivors, those small, unnoticed reptiles, were waiting. They were the inheritors of catastrophe. In the silence that followed the Great Dying, evolution began again. Competition returned, slowly at first, then faster. Plants adapted to the changed atmosphere, spreading across the land once more. Animals diversified to fill the empty niches. Life was reawakening, and when it did, it came back stronger. The new reptiles evolved into diverse forms, some small and agile, others massive and armored. The first dinosaurs appeared, still small and unassuming, but destined for greatness. The oceans, once barren, filled again with fish, mollusks, and ammonites. Coral reefs returned, rebuilt from the rubble of extinction. Oxygen levels rose, temperatures stabilized, and the air, once again, shimmered with the breath of life. The Earth had survived its darkest hour. The Great Dying had nearly ended the story of life, but instead, it had rewritten it. From that destruction would come the most spectacular era of creatures ever to walk the planet. Towering giants, flying beasts, and ancient predators, all born from the ashes of extinction. But for now, the world was still quiet, still healing. The forests were young, the seas shallow, the air fresh and thin. The memory of fire still lingered in the soil. And above it all, the sun rose on a new world, a world reborn from ruin. Life had proven once again that it could endure anything. Fire could not kill it. Ice could not silence it. Extinction could not erase it. The earth had been burned, poisoned, and drowned, but it still turned, still breathed, still lived. And in that resilience lay the truth of its story, that every ending, no matter how final it seems, is only the beginning of something greater. The silence after the great dying was long. The forests were gone, the oceans nearly empty, and the sky still heavy with the breath of volcanoes. For a while, the earth felt hollow, as though life itself had given up. But slowly, patiently, the planet began to heal. Rain fell again, washing ash into the seas. Rivers carved through dead valleys, carrying minerals into the water. Sunlight broke through the haze, and warmth returned. And once again, life rose from the ruins. It began small, as it always did. Algae bloomed in the oceans, turning the water green. Coral colonies returned, building new reefs upon the bones of the old world. Shellfish, ammonites, and fish evolved into new forms. Every wave, every current carried the seeds of rebirth. On land, ferns and conifers spread once more, carpeting the continents in green. Insects buzzed through the air, returning to the forests that had been ashes. Small reptiles scurried between roots and stones, hunting for food, basking in the sunlight of a quieter world. And among them were the ancestors of something extraordinary. From a group of small, agile reptiles came the first true archosaurs, the ancestors of crocodiles, pterosaurs, and dinosaurs. They were lean, fast, and efficient, built for survival in a world that had only just begun to stabilize. Their lungs were powerful, their hearts strong, their legs positioned beneath their bodies, giving them speed and endurance no creature before had possessed. These new reptiles quickly dominated the land. While the synapsids, the once great rulers of the Permian, dwindled into small, burrowing forms, the archosaurs flourished. Evolution favored their adaptability. And within a few million years, the first dinosaurs appeared. At first, they were small, no larger than dogs, running on two legs, hunting insects and small prey. But the world they inhabited was one of opportunity. The extinction had cleared the planet of competitors. Leaving open space and resources, life began to diversify at an astonishing pace. As the Triassic period unfolded, dinosaurs evolved into many forms. Some grew longer limbs and sharper teeth, becoming swift predators. Others grew stronger jaws and massive bodies, turning into plant eaters capable of felling entire trees. The balance of predator and prey returned, and the Earth once again teemed with movement and sound. The climate was warm and dry. Much of Panjia remained intact, its interior covered in vast deserts. But along the coasts, lush forests and river valleys thrived. Conifers reached high into the sky, and cycads spread across the ground like living carpets. In these forests, early dinosaurs hunted and grazed. Crocodile-like creatures lurked in rivers, ambushing anything that came close. Pterosaurs, the first flying reptiles, soared above, gliding on leathery wings, watching the world below. The Triassic was a time of experimentation. Life was testing new forms, stronger, faster, more efficient. But it was also a time of instability. Volcanic eruptions continued to shape the land, and the supercontinent Panjia began to crack As it did, new seas formed between the splitting land masses, changing weather patterns and isolating ecosystems. And then, as it had so many times before, the world changed suddenly. Another extinction swept across the planet, smaller than the Great Dying but still devastating. Volcanic activity darkened the sky and poisoned the air. Many reptilian groups vanished. The old rulers of the Triassic were gone. The survivors were the dinosaurs. With their efficient lungs, upright stance, and adaptability, they thrived where others perished. When the dust settled, they inherited the world. And so began the Jurassic, the true age of dinosaurs. The continents were breaking apart, and with that came new coastlines, oceans, and climates. Rain returned to the interior lands, transforming deserts into forests. Rivers and lakes formed, teeming with fish and vegetation. The planet was alive again, warmer, wetter, and full of energy. Dinosaurs grew to enormous sizes. Massive herbivores like Brachiosaurus and Diplodocus wandered through the forests and plains, their necks stretching high to feed on the treetops. Herds moved together across vast landscapes, shaking the ground beneath their feet. Predators evolved alongside them, fearsome creatures like Allosaurus and Ceratosaurus, built for strength and precision, their jaws lined with serrated teeth. The air above was ruled by pterosaurs. They soared through the sky with wingspans greater than a man's height, diving toward rivers to snatch fish from the water. Their shadows passed over herds below, reminders that the world was no longer ruled by the small or the weak. And beneath the surface of the oceans, another revolution was underway. Marine reptiles, descendants of land-dwelling creatures, had returned to the water, evolving into graceful giants. Ichthyosaurs swam like dolphins, sleek and fast, while plesiosaurs glided with long necks and powerful flippers. The seas that had once been barren now teemed with life. From pole to pole, the planet thrived. The forests of the Jurassic were lush and green, filled with cycads, conifers, and ferns. Insects hummed through the air, pollinating plants that would one day evolve into flowering species. The oxygen-rich atmosphere fed giant bodies and massive ecosystems. The sound of the world was no longer silence, but the deep, rhythmic breathing of life on an immense scale. And among this abundance, new possibilities began to form. Some dinosaurs grew feathers, not yet for flight, but for warmth and display. These simple coverings, bright and patterned, marked the first step toward a new kind of creature that would one day rule the skies. Others began to develop sharper intelligence, complex social behavior, and communication through sound and movement. The Jurassic world was not just alive, it was aware. But even in this paradise, the forces of change never rested. As the continents drifted farther apart, climates shifted again. Rainforests gave way to drier plains. New species evolved to adapt to the changing world. The Cretaceous period dawned, bringing both splendor and foreshadowing. Flowering plants appeared for the first time, painting the world in color. They attracted insects that evolved alongside them, bees, butterflies, and beetles that carried pollen across the winds. The air was fragrant, filled with the hum of a new kind of symbiosis. Herbivorous dinosaurs grew more specialized to feed on these plants. Triceratops with its horns and frill, Ankylosaurus armored in bone plates, hadrosaurs with elaborate crests for sound and communication. Predators evolved too, becoming faster, smarter, deadlier. Among them was the Tyrannosaurus, the apex hunter of its time, massive, intelligent, and terrifyingly efficient. The oceans were ruled by mosasaurs and giant sharks. while the skies belonged to pterosaurs the size of aeroplanes. Everywhere on the planet, life had reached its peak. It was the age of giants, of dominance, of perfection. But perfection never lasts. Beneath this golden age, the planet's rhythm was already shifting. Volcanic activity began to increase again. The air thickened with carbon dioxide, and the climate grew unstable. Sea levels rose, drowning coastlines and forests. Some species began to disappear quietly, their time fading as conditions changed. And then, far across the galaxy, a rock began to fall. It would take millions of years to reach the Earth, but its journey had already begun, a silent messenger of extinction. For now, though, the dinosaurs ruled unchallenged. They filled every corner of the planet, from humid jungles to icy shores. Their footsteps echoed across the continents, their roars across valleys. The Earth belonged to them in every sense. They had risen from the ashes of the great dying, conquered land, sea, and sky, and shaped the planet in their image. And though their reign would one day end in fire, their legacy would never fade, because from their bones and their feathers, from their blood and their instincts, the story of life would continue. But that was still far ahead. For now, the Earth basked in its greatest age of life and power, a world alive with thunder, motion, and breath. The age of dinosaurs had reached its zenith, and as the sun set over the forests of Panjia's broken lands, the shadows of giants stretched across the Earth, the last light of a world before the fall. The world had entered an age of wonder. The Earth was warm and lush, the air thick with life. Forests of towering conifers and ferns blanketed the continents, stretching from horizon to horizon. Rivers wound through plains alive with movement, and the skies were filled with the cries of creatures whose wings spanned the length of houses. This was the age of the giants, the height of the dinosaurs' reign. The continents that had once been united as Pangaea were now drifting apart, pulled by the slow, relentless motion of the planet's crust. The shifting plates opened new oceans, shaping coastlines and climates. Warm seas lapped against green shores, and inland deserts gave way to humid jungles. The world was alive in every direction, a planet overflowing with vitality. Herds of colossal herbivores moved across the plains. Brachiosaurs, taller than buildings, reached into the treetops, stripping branches with gentle precision. Their massive hearts pumped blood through necks as long as city streets, keeping their heads high above the forests. Nearby, stegosaurs grazed, their backs lined with plates that shimmered in the sunlight. Triceratops' locked horns in thunderous duels, shaking the ground beneath them. The sound of the earth itself had changed. It no longer echoed with silence or wind, but with the footsteps of creatures whose weight could crush stone. And where there were giants, predators followed. Allosaurus, with its razor teeth and keen senses, hunted the open plains. Packs of smaller carnivores darted between ferns, working together to take down prey far larger than themselves. Later came Tyrannosaurus, the embodiment of power and precision. Its bite strong enough to crush bone, its intelligence unmatched among its kind. Each roar that echoed through the forests was a declaration of mastery, a reminder that this was their world. But not all dinosaurs were titans. In the shadows of the giants, smaller species thrived, feathered hunters, no larger than a human, darting through the underbrush in search of insects and lizards. Some leapt through the air with feathered limbs, gliding between branches. Evolution was experimenting again, testing the limits of form and flight. The first true birds appeared descendants of small, feathered dinosaurs that had learned to master the air. Their hollow bones made them light, their feathers refined for balance and lift. They soared above the forests that had once belonged only to reptiles. Below, the oceans were just as alive. Marine reptiles ruled the seas as completely as dinosaurs ruled the land. Plesiosaurs with long necks glided through the depths, their flippers cutting through the water with perfect rhythm. Ichthyosaurs darted like torpedoes, their sleek bodies built for speed. And in the later Cretaceous, the oceans belonged to the mosasaurs, massive predators that could swallow sharks whole. The coral reefs teemed with life, shimmering with colors unseen on land. Ammonites drifted through the currents, their spiral shells catching sunlight as they rose and fell with the tides. Giant turtles and fish swam between reefs, while storms above churned the surface into chaos. The cycle of life and death played endlessly, shaping evolution with every passing wave. On land, the plants were changing too. For the first time, flowering plants began to bloom, a quiet revolution that would reshape the planet forever. Their bright petals attracted insects, beginning a partnership that would dominate the future. Bees, butterflies, and beetles spread pollen from flower to flower, creating new species faster than any age before. Color had arrived on Earth, and with it came fragrance, variety, and beauty. The dinosaurs adapted. Herbivores evolved specialized jaws to chew the new plants, while carnivores grew faster and smarter to keep up with them. The ecosystems of the Cretaceous became more intricate than ever, each creature fitting perfectly into the web of survival. Above the forests, pterosaurs ruled the skies. They grew to unimaginable sizes, some with wingspans over 10 meters. They soared across continents, gliding on thermal winds, diving toward rivers to catch fish. Their calls echoed across valleys, their shadows sweeping over herds below. The Earth, at its core, was stable and warm. There were no great ice caps, no frozen poles, only lush forests stretching even to the edges of the world. Volcanoes still erupted in distant lands, but their fury was balanced by the endless green of the biosphere. Oxygen filled the air, feeding the massive bodies that roamed the land. From space, the planet glowed with life. Blue oceans, green continents, white clouds swirling gently in the sunlight. It was a paradise forged through fire, extinction, and time. But even paradise carries the seeds of its end. Beneath the surface, the Earth's crust was restless. Tectonic forces shifted the continents, pushing mountains higher, opening rifts that spewed lava into the seas. The oceans changed their chemistry as volcanic gases dissolved into the water. Slowly, quietly, the balance began to shift. The climate warmed further. Some regions grew dry, others flooded. New plant species spread, while old forests vanished. Entire ecosystems migrated with the changing weather. And still, the dinosaurs thrived. They were the perfect survivors of their time, diverse, adaptable, and unstoppable. From the smallest feathered raptor to the massive sauropods that moved like living mountains, every continent was theirs. Their dominance lasted for more than 160 million years longer than the entire history of humanity multiplied many times over. In this golden age, the boundaries between sky, sea, and land blurred. Birds filled the air, reptiles ruled the oceans, and the ground trembled with giants. The planet had reached its peak, a fully living, breathing system where life controlled the balance of the atmosphere, the soil, and even the temperature itself. The Earth had never been so alive, but far above, unseen and unnoticed, something was coming. A rock no larger than a city drifted through the void of space for millions of years. It moved in silence, pulled by the gravity of the sun. its orbit shifted, intersecting with that of the Earth. Its path was written long before the first dinosaur ever walked, and as the world continued in its endless rhythm, the asteroid drew closer. The skies were still bright, the oceans still calm. The dinosaurs grazed, hunted, and lived as they always had. The planet was unaware of the shadow that was falling toward it, a shadow that would erase almost everything in a single moment. But before that moment, there was only peace. Forests whispered in the wind, herds crossed open plains, and the world glowed beneath the sun. It had been a journey of unimaginable persistence, from molten rock to living planet, from microscopic cells to creatures that could shake the ground with their footsteps. The reign of the giants was the culmination of everything life had achieved: strength, diversity, balance, and beauty. And soon, it would all end. But endings on Earth are never truly endings. Every extinction is a transformation. Every fall, a beginning. The age of dinosaurs would burn away in fire. But from its ashes, something entirely new would rise. Small, fragile, intelligent, and destined to inherit the Earth. For now, the giants still walked, unaware of the stars aligning above them. The wind moved through the forests, carrying the calls of creatures whose names would one day be whispered by their distant descendants. And high above, beyond the clouds and the blue, the messenger of extinction drew near, invisible, unstoppable, and already written into the story of life itself. The reign of the giants was nearing its final sunset. The Earth was about to change again. It began with silence, a calm so perfect, so complete, that even the forests seemed to hold their breath. The morning sky over the Yucatan Peninsula was cloudless, the air thick with warmth. Herds of triceratops grazed among ferns, and above them, pterosaurs drifted on lazy currents of wind. In the distance, the calls of predators echoed faintly, the familiar rhythm of a living world. But high above the clouds, far beyond sight or sound, something moved through the blackness. A rock, 6 miles wide, ancient and indifferent, falling toward the Earth at 60,000 kilometers per hour. It had been traveling through space for millions of years, its path guided by gravity and chance, and now its journey was ending here, on this green and thriving planet. For a few fleeting moments, the world below continued unaware. Leaves swayed in the wind. Insects buzzed in the humid air. Waves rolled gently against tropical shores. The planet, alive and unaware, turned beneath its doom. Then the sky caught fire. The asteroid entered the atmosphere, compressing air before it, faster than sound could escape. The friction ignited the air itself, transforming the heavens into a streak of blinding white. Trees burst into flame instantly as a column of light tore across the horizon. The roar of its descent shook the Earth long before it struck, and then impact. The asteroid slammed into shallow sea, vaporizing water and rock in a single heartbeat. Temperatures at the point of impact rose higher than the surface of the sun. Everything within hundreds of kilometers disintegrated instantly. The ocean boiled away. The Earth's crust rippled like water, throwing up a shockwave that circled the globe. A fireball rose into the sky, a sphere of molten earth and vaporized stone, climbing higher than any mountain before, collapsing back into the atmosphere. Billions of tons of debris were launched into space, only to rain back down moments later as a storm of fire. The blast wave flattened forests thousands of kilometers away. Tsunamis hundreds of meters high raced across oceans, smashing into continents, erasing coastlines. The ground quaked for hours, mountains crumbled, and the air turned to flame. In the aftermath, darkness began to fall. The impact had thrown dust, ash and sulfur high into the stratosphere, blocking out the sun. Day turned to twilight, twilight to night. For weeks, then months, sunlight struggled to reach the surface. Photosynthesis stopped. The great forests that had fed the world began to die. The air grew cold. Wildfires raged across continents, ignited by falling debris and burning vegetation. Smoke and soot joined the dust already, choking the atmosphere. The planet burned, then froze. The age of the dinosaurs was ending. The creatures that had ruled the world for 160 million years tried to endure. Herds of herbivores wandered through dying forests, searching for food that no longer grew. Predators starved, their roars fading into silence. Even the mighty Tyrannosaurus, the king of the late Cretaceous, could not escape the collapse. In the seas, life fared no better. The oceans turned dark and acidic as carbon dioxide from the fires dissolved into the water. Plankton, the base of the marine food web, vanished. The great marine reptiles, the mosasaurs and plesiosaurs, starved and sank into the depths. The sky, once filled with pterosaurs, grew empty. For months, the sun remained hidden behind a shroud of dust. The temperature plummeted. Plants withered. Animals froze. Ecosystems that had taken millions of years to form unraveled in a geological instant. And yet, even in this apocalypse, some life clung on. Small creatures hid underground or in the cracks of trees, burrowing mammals no larger than rats, fed on seeds and roots buried beneath the soil. Their warm bodies and fast metabolisms gave them an advantage in the cold. Crocodiles, turtles, and some birds found refuge in water or hibernation, surviving the long darkness. For all others, the age was over. 3/4 of all species on Earth vanished. The giants that had ruled land, sea, and sky were gone. The last echoes of their world faded into silence. The final footstep, the final breath, the final heartbeat of the dinosaurs' reign. Then, slowly, the dust began to settle. Years passed before sunlight returned to full strength. The planet, though scarred, began to heal. The air cleared, the temperature rose again. Rain returned, washing soot and ash into the oceans. New plants sprouted from surviving seeds. At green returned to the land, and in that green, small animals emerged, the survivors of the darkness. Mammals, once small and hidden in the shadows of the dinosaurs, began to multiply. They scavenged the remains of the old world, eating insects, eggs, and anything they could find. Birds, descended from the feathered dinosaurs that had taken to the skies long before the fall, filled the forests with new songs. The world was quieter now, emptier, but it was not dead. It was reborn. From the ashes of extinction came opportunity. The mammals grew larger, smarter, and more diverse. Their warm-blooded bodies allowed them to adapt to the changing climates. They evolved rapidly, filling the niches left empty by the dinosaurs. Small, nocturnal creatures became omnivores, herbivores, and hunters. In the seas, new species of fish and whales began to appear. In the skies, birds evolved new forms and colors. Life was beginning again, cautious, resilient, unstoppable. The asteroid had destroyed the age of the giants, but it had also opened the door to a new world, one that would eventually belong to creatures capable not just of survival, but of thought, memory, and reflection. The impact that ended the dinosaurs' reign would, millions of years later, give rise to the age of humanity. The Earth, scarred and changed, continued to turn. Forests regrew, mountains eroded, continents drifted. Time moved forward, erasing the traces of fire and darkness. But deep beneath the ground, the bones of the lost world remained silent witnesses to the day the Earth almost died. And still, above all the destruction, one truth endured. Life always finds a way. For every extinction, there is rebirth. For every ending, a beginning. The asteroid had ended one chapter in Earth's history and begun another, the story of mammals, of evolution's next great experiment, and ultimately, of us. And though the dinosaurs were gone, their legacy endured in every bird that took flight, in every fossil beneath the soil, in every reminder that the world we know was built upon the ashes of their kingdom. 66 million years had passed since the Earth burned. The sky was blue again, the oceans calm. The planet had recovered, but it would never be the same. The age of giants was over. The age of survivors had begun. And somewhere, in a quiet forest of the New World, a small mammal lifted its head, sniffed the air, and took its first cautious steps into the future, unaware that it was walking into the beginning of a new age and the inheritance of a fallen world. The fire had ended, the silence had lifted, and the story of life, once more, continued. When the fires faded and the skies cleared, the Earth was a different world. The great thunder of the dinosaurs had ended. Their bones lay buried beneath layers of ash and time, silent beneath the reborn forests. In their place, a quieter world began to emerge, a world ruled not by giants, but by the small, the clever, and the adaptable. The survivors of the apocalypse were humble creatures. Small mammals, no larger than rats, crept through the undergrowth, feeding on seeds, insects, and carrion. Birds filled the skies once more, descendants of the few dinosaurs that had escaped extinction. Reptiles lingered, but their age had passed. The torch had been handed to a new lineage. The mammals began to change. Freed from the shadow of the dinosaurs, they spread across the continents, exploring every corner of the Earth. Evolution, always patient, now accelerated. Some mammals returned to the sea, their limbs reshaping into flippers, the ancestors of whales and dolphins. Others took to the air, gliding between trees as early bats. And on land, they grew larger, stronger, and more diverse than ever before. Forests covered much of the planet once again. The air was rich with oxygen, the climate warm and stable. It was a time of abundance. Fruit-bearing plants had spread widely since the Cretaceous, offering new food sources that fueled the evolution of primates, mammals built for climbing, grasping, and seeing. In the dense jungles of the Paleocene, the first primates appeared. They were small, nimble, and intelligent, with forward-facing eyes that allowed depth perception, a gift that would one day change everything. They leapt from branch to branch, hunting insects and fruits, living in social groups that relied on communication and cooperation. As the Eocene dawned, the world grew even warmer. Tropical forests reached the poles and life flourished. Mammalian evolution exploded once again. Massive herbivores roamed the plains, the ancestors of horses, elephants, and rhinoceroses. Carnivores evolved into wolves, cats, and bears. The first whales, still partly land-dwelling, began their long transformation into fully aquatic giants. The Earth was alive again, in balance and motion, but balance never lasts forever. Beneath the surface, the continents continued to drift. Mountain ranges rose, oceans opened and closed. The collision of India with Asia lifted the Himalayas, reshaping global weather. These slow movements of stone altered everything: rainfall, temperature, and the pattern of life itself. As the climate cooled, the forests began to shrink. Grasslands spread across the continents, vast open plains that invited a new kind of creature, fast, strong, and enduring. Herbivores evolved long legs and flat teeth for grazing tough grass. Predators became faster and more coordinated, learning to hunt in packs. And among the trees that still stood, the primates watched, learned, and adapted. By the Oligocene, the planet had grown cooler and drier, and many tropical species vanished, replaced by mammals adapted to the open savannas. Elephants grew tusks to dig for roots. Camels and horses spread across the plains. Cats evolved sharper claws, better eyes, and silent steps. The story of life had shifted once more from the dominance of size to the dominance of intelligence and adaptation. In Africa, the primates continued to evolve. Some stayed in the trees, while others ventured to the ground. They began to walk more upright, balancing on two legs for short distances. Their hands grew more dexterous, their eyes sharper, their brains larger. They were the early apes, the ancestors of chimpanzees, gorillas, and humans. For millions of years, they lived simple lives, eating fruit, building nests, and traveling in groups through the forests of Africa and Asia. But the Earth was still changing, and change is the only constant that drives evolution forward. Around 5 million years ago, the climate shifted again. Forests thinned, replaced by grasslands, and the world grew cooler, and food grew scarcer. Survival favored those who could adapt, those who could think, plan, and use their hands for more than climbing. And from that crucible of change, something remarkable began. A species of ape stood taller than before. It began to walk upright more often, freeing its hands to carry food and tools. It learned to shape stones into blades, to crack bones for marrow, to use the environment not just as a home, but as a weapon. This was the birth of the genus Homo. They were not yet human, but they were close. Their brains were larger, their faces flatter, their hands capable of precision. They hunted in groups, shared food, and cared for their young. Cooperation had become their greatest strength. These early humans spread across Africa, following rivers and herds. They built shelters, used fire for warmth and protection, and learned to speak at first in gestures and sounds, then in language. The world around them changed again. Ice began to spread from the poles, covering vast regions of the planet. The Pleistocene ice ages had begun. Glaciers advanced and retreated in cycles, carving mountains and reshaping continents. The cold forced adaptation on every species. Mammoths, covered in thick fur, roamed the tundras. Saber-toothed cats hunted the icy plains. Herds of bison, horses, and reindeer grazed on frozen grasslands. It was an age of giants once more, but this time the giants were warm-blooded, intelligent, and strong, and among them walked early humans. They learned to craft better tools, to build shelters from bones and hides, to create clothing to survive the cold. They followed herds across continents, crossing ice bridges and migrating into new lands. Fire became their constant companion. Warmth, safety, and light in a world of endless winter. They painted the walls of caves with images of the animals they hunted, symbols of both reverence and memory. They buried their dead, honored their ancestors, and told stories around fires that glowed in the darkness. Somewhere in this long twilight of ice and evolution, humanity was born. Our species, Homo sapiens, appeared roughly 300,000 years ago. Intelligent, adaptable, and curious. We spread faster than any creature before us. From Africa, we crossed into Asia, Europe, and beyond. We built rafts to reach islands, tools to shape the world, and words to shape our thoughts. We hunted, farmed, built, and dreamed. The mammals had risen from the ashes of the dinosaurs, and from them came creatures capable of understanding the stars, the seasons, and the story of life itself. But the road to this point had been paved with catastrophe and chance. From the first spark of life in the ancient oceans to the fall of the dinosaurs, from fire and ice to thought and language, every step had been part of a vast, unbroken chain. And yet, even now, the same forces that shaped the dinosaurs still shape us. Volcanoes still breathe fire. Asteroids still circle the sun. The planet still shifts and trembles beneath our feet. We are not separate from this story, we are its continuation. The rise of mammals and humans was not the end of evolution, but another verse in the planet's endless song. The Earth had survived 5 mass extinctions, countless upheavals, and unthinkable odds. Through it all, life had adapted, evolved, and endured. And now, standing at the edge of time, humanity was both a survivor and a steward. The first species capable of understanding the story written in stone. The first to know how fragile it all truly is. The rise of mammals was the rise of thought. The rise of humans was the rise of awareness. And through that awareness, the Earth finally looked back at itself, not through instinct or movement, but through eyes that could wonder. The journey that began in darkness, in heat and chaos, had reached consciousness. Life had learned to see. And in the reflection of the stars, the story of the Earth from dust to mind was finally understood. The Earth had turned through billions of years through fire, ice, and darkness to reach this point. The story that began in the chaos of creation had found its most unlikely narrator, humanity. 2 million years ago, the planet was cold and wild. Ice sheets stretched across the northern continents, carving valleys and mountains. Tundras, forests, and savannas covered the world in shifting patterns as the climate changed with each passing age. It was here, amid this rhythm of ice and thaw, that humans began their long ascent. They were hunters, wanderers, and survivors. They followed herds across plains, tracked rivers to their sources, and learned to adapt to every environment the planet offered. Fire became their companion, not just a source of warmth, but a tool, a force to shape the world. They learned to make tools of stone, then of metal. They built shelters, then villages. The Earth, once indifferent to its inhabitants, now began to bear the marks of their presence. The first humans looked at the stars and saw more than light. They saw meaning. They named the constellations, painted the walls of caves, and buried their dead with care. They were not the strongest, nor the fastest, but they had something no creature before had ever possessed: the ability to imagine what could be. Through imagination came invention. Through invention came civilization. As the ice retreated, humanity spread across the continents. They crossed mountains and seas, built cities along rivers, and tamed the land. Forests that had stood since the age of the mammals fell beneath their hands, transformed into homes and fields. They learned to plant and harvest, to domesticate animals, to store food. For the first time, a species had freed itself from the mercy of nature. Villages became towns, towns became cities, and cities became empires. Stone gave way to bronze, bronze to iron, and iron to steel. They built monuments to gods and kings, carved from the same stone that once held the fossils of ancient worlds. They charted the skies, measured time, and learned to write the story of their own existence. But with every step forward, they changed the planet itself. Forests disappeared. Rivers were redirected. Species vanished. Mountains were mined, and oceans were crossed. Humanity's reach stretched farther than the horizon, touching every corner of the Earth. For the first time, one species had become a geological force. The Earth's atmosphere began to shift again, not from volcanoes or asteroids, but from machines and fire. The same carbon once trapped in the forests of the Carboniferous, the same fuel buried by time, was brought back to the surface and burned. Smoke rose once again into the sky, just as it had in ages past. But this time, the fire was not nature's doing, it was humanity's. The temperature began to rise. Ice melted. Seas crept inland. Storms grew stronger. Forests burned faster. The delicate balance the Earth had maintained for millions of years trembled beneath the weight of human progress. And yet, in the midst of this transformation, humanity looked up once more. For thousands of generations, they had gazed at the stars and wondered where they came from. Now they knew. They discovered the age of the Earth, the birth of the universe, the structure of life itself. They learned that the same elements in their bodies were born in the hearts of ancient stars that they were, in every sense, the universe made conscious. They built telescopes that reached back in time, satellites that circled the Earth, and machines that could speak and think. They split atoms, mapped genomes, and touched the surface of the moon. In just a blink of geological time, they had transformed from simple toolmakers into the architects of their own destiny. But that destiny now hung in the balance. The future of the planet of all life lay in their hands. They had the power to destroy or to protect, to consume or to create. The Earth, once shaped only by volcanoes and asteroids, now waited on their choices. The forests that had given them breath were dying. The oceans that had given them food were warming. The air that had sustained their species since the dawn of time was filling with smoke. And yet, the same mind that caused the problem could also solve it. Humanity began to awaken to its own impact. They built technologies to capture carbon, to harness wind, water, and sunlight. They planted forests where deserts had spread. They looked once again at the stars, not with conquest, but with curiosity, seeking new worlds while trying to save their own. The story of Earth was not finished. It had simply entered a new chapter, one written by the only species capable of reading it. But the planet will continue, with or without them. The continents will keep drifting. Mountains will rise and fall. The oceans will reshape the coasts. In another 100 million years, the face of the Earth will look nothing like it does today. Cities will crumble, languages will vanish, and new forms of life will emerge to fill the spaces humanity leaves behind. If history has shown anything, it is that life endures. After every catastrophe, after fire, ice, and impact, something new has always risen. Perhaps, long after humanity is gone, the descendants of some small surviving creature will look at the stars and wonder who came before them. Perhaps they will find our fossils buried beneath layers of new rock, just as we found the bones of dinosaurs and the imprints of ancient fish. And they, too, will learn that life is not a straight line, but a cycle. Every extinction is followed by creation, every silence by song. From the first spark of chemistry to the birth of consciousness, the Earth's story has been one of transformation from dust to stone, from stone to life, from life to thought. And through it all, one truth has remained constant. The planet always finds a way to continue. The Earth was born from destruction. It grew through chaos. It thrived through balance. It survived through death. and it became aware through us. Now, as the Earth spins beneath the stars, humanity stands at a crossroads. The same fire that once forged their tools now fuels their cities. The same curiosity that once led them to cross rivers now drives them to explore the universe. They are the inheritors of 4.5 billion years of evolution, the latest expression of life's determination to exist. But the question remains, how long will they last? The Earth will outlive them, as it has outlived everything before. One day, the Sun will expand, turning red and vast, consuming Mercury, Venus, and perhaps the Earth itself. The oceans will boil away, the mountains will melt, and the last traces of life will vanish. But even then, the atoms that once formed living beings will drift into space, joining the dust that forms new stars, new planets, and maybe, somewhere far away, new forms of life. The story will begin again, and perhaps, in some distant future, another world will look to its skies, wonder where it came from, and tell its own version of this same story. For now, the Earth continues vibrant, fragile, and alive. Its continents shift, its winds move, its forests whisper, its oceans breathe. And somewhere on its surface, a single species looks up at the night sky and realizes that it is both the observer and the observed universe looking back at itself. The journey that began in fire ends in thought. The story that began in chaos ends in awareness. And in that awareness, the Earth, for the first time, understands what it truly is. Not a planet of dust and stone, but a living, thinking world capable of remembering its own beginning. The age of humanity is not the end of the story. It is the story realizing it exists. And the future of Earth, whatever it may be, will always begin the same way, with one eternal truth whispered through time: life endures.